Number 1 says, suppose that you are on a dock at Blue Point Beach. At 2 p.m. on November 3rd, the tide is in, so it means the water is at its deepest. At that time, you find the depth of the water at the end of the pier is 7 meters. At 8 p.m., okay, so this is 6 hours later, on the same day, the tide is out, which means the water is at its shallowest, and you find the depth of the water is 3 meters. Assume the depth of the water varies sinusoidally with time. All right, part A wants us to, on the axes that we're given, they want us to sketch a graph of this scenario for 2 full periods. All right, so first thing we have to do is we have to label our axes. And if we know that to go from high tide to low tide takes 6 hours, right, from 2 p.m. to 8 p.m., well, we know that it's going to take another 6 hours to get back up to high tide. So altogether, one cycle, one period, is going to be 12 hours. So since they want us to, graph 2 complete cycles, we're going to need to label up to 24 hours on our x-axis, or in this case, our t-axis. All right, so I just chose to jump by 2s. I thought it would fit a little nicer. All right, so then we know that high tide is, the water is at 7 meters, and low tide, the water is at a height of 3 meters. So along our y-axis, or in this case our d-axis, what we're going to do is we're going to number up to 7. All right, so they tell us at 2 p.m. the tide is at 7 meters high. Now, they do say to let t equal 0 represent noon. So 2 p.m., this right here, we're going to put a point. This is, where 2 p.m. would be. We're going to put a point all the way up here at 7. So 2, 7. All right, so then at 8 p.m., the tide is down to 3 meters. So at 8, we're going to go up to 3 and put a point. And basically what's going to happen is every 6 hours it's going to repeat this process. So 6 hours after 8 o'clock would be right here at 14, right? 8 plus 6 is 14. So at 14, I'm going to go up to 7 again and put another point. Okay, and then 6 hours later, so 14 plus 6 would bring us to 20. So we're going to put a point at 23. Okay, 20 hours after 12 p.m., the tide is down to 3 feet again. All right, so now we're not really going to be able to complete another cycle to fit, 6 hours later, because we only numbered up to 24, and we would have to make it to 26 to get up to a height of 7 again. So we're not going to have another high tide point. But what we can do, just to make our graph a little bit more accurate, is if we want to find the midway point, okay, if we want to find the midline between 3 and 7, well, the middle of 3 and 7, right, the average of 3 and 7 is right here at 5. So what's going to happen is it's going to be at a height of 5 halfway between 2 and 8. So halfway between 2 and 8 is at 5. So we could plot a point right here at 5, 5. Okay, so every 3 hours after high tide or low tide, it's going to be at a height of 5 again. So if I take 8 and add on 3 hours, right, 1, 2, 3, it's going to bring me at a height of 5. So that gives us 11, 5. So then 3 hours later, 1, 2, 3, we're at high tide again. 3 hours later, 1, 2, 3, we're going to be at a height of 5 again. All right, so then 3 hours later, so 1, 2, 3, we're down at low tide. 3 hours after this, 1, 2, 3, we're going to be up at a height of 5 again. And again, how we're getting the 3 hours is because the difference between high tide and low tide is 6 hours. So halfway through, the tide is going to be halfway between a depth of 3 feet and a depth of 7 feet. All right, so at this point, we can go through and we can connect. So the graph is going to kind of come up here. It's going to go through all of our points. It's a little hard to connect on this, but I'm just going to do the best I can. And I'm going to end off right about here, okay? I don't want to go all the way up to 7 because, remember, we would have to reach our 26 for this to be at a height of 7. All right, and I'm just going to label this for right now d of t, the depth in terms of the time, because we don't know the equation. Part B is what's going to ask us to find our equation. Okay, so Part B wants us to derive an equation, and you can really make any sinusoidal curve a sine curve or a cosine curve, but to me, this one, it looks a little bit easier to work with cosine. And I'm really just going to focus in on from here to here, because this would be a complete cycle of a cosine curve. All right, so here's our general format of a cosine curve, where A is our amp, B is our frequency, C is our horizontal shift, and D is our vertical shift. And instead of using X and Y, I'm just using T, because we're using time as our x-axis. And this just refers to D of T, the depth in terms of time. All right, so let's go through and find each component of this equation. All right, so let's start with this right here, the A, the amplitude. So if we want to find the amplitude, we know that the amplitude is going to be equal to the max minus the min divided by 2. All right, well, the maximum is right here at 7 feet, and the minimum is right here at 3 feet. So we'll just do 7 minus 3 divided by 2. So 7 minus 3 is 4, and 4 divided by 2 is 2. So that's our amplitude. Now, I'm going to just kind of go through and plug these in as we go. So I could write D of T equals, and you have to decide whether you're going to use a positive 2 for A or a negative 2. Since our curve, since we're using this as our starting point, since our curve is starting high, dropping down low, and coming back up high, this would be a positive cosine curve. So if it was going the other way, if it started low, came up high, and dropped back down low, that would be a negative cosine curve. But since it's positive, I'm going to write positive 2 and then cosine. All right, the next thing I'm going to do is I want to find my frequency. Now with this curve, we can't really just tell by looking at it what the frequency is, because whenever, it's numbered in terms of pi, you can do that. But when we have numbers down here, we're going to have to use our period formula to help us find the frequency. Now we know that in our formula, period is equal to 2 pi over our frequency. Now the period is just the horizontal length of one complete cycle. So horizontally, we're going from 2 up into 14 to complete this cosine curve. So 14 minus 2 is 12. So it takes 12 units to complete this cosine curve. So the period is going to be 12. So I'm going to replace this period with a 12. All right, and that's going to be equal to 2 pi. Usually when we solve for the frequency, we call it B, because it's our B in our formula. All right, so let's just put this 12 over 1, and we'll cross multiply to solve. So 12 times B is 12B. And then 2 pi times 1 is 2 pi. And to get the frequency, to get the B by itself, we just divide both sides by 12. So that leaves us with B equals, well, since 2 over 12 simplifies to 1/6, we're really left with 1 pi over 6, which is just pi over 6. So I can go ahead and substitute pi over 6 into the formula for B. All right, then we're going to have T minus. Now in parentheses, the C is your horizontal shift. So we had to shift horizontally 2 units to the right to start our cosine curve. So after I bring down this minus sign, I'm going to replace this C with a 2. All right, and the last component of our formula is just really finding this D right here, our vertical shift. If you want to apply the formula for finding your vertical shift is really just to take your maximum value and subtract the amplitude from it. So since our maximum value is 7, and we found the amplitude to be 2, we can just say 7 minus 2. So the vertical shift is 5. And so we can replace this with a 5 in our formula. And it makes sense if you look at the graph that the vertical shift is 5, because 5 would be, y equals 5 would be the midline of our graph. Okay, so anyway, here's our answer for part B. Number 2 says the tides in a particular bay can be modeled with an equation in the form that we have right here, where T represents the number of hours since high tide and D represents the depth of the water in the bay. All right, it tells us the maximum depth of the water is 36 feet and the minimum depth is 22 feet, and high tide hits every 12 hours. All right, so part A says on the axes, sketch a graph of the scenario for two full periods. So if high tide is hit every 12 hours, 2 full periods is going to take 24 hours to occur. So we can label our x-axis up to 24. You can choose to jump by whatever you want. I mean, I chose to jump by 3s here. Now, along the y-axis, or in this case, the d-axis, they tell us that low tide is 22 feet and high tide is 36 feet. So we're not really going to need to use any numbers lower than 22. So if you want to just kind of use a little interval break here, that's a pretty bad one, but you could put that there and you can start right at 22 feet. And again, you can jump by whatever you want. I'm going to jump by 2s. All right, so they tell us to let t equals 0 represent high tide, and we know high tide is at a depth of 36 feet, so at 0, 36, I'm going to put a point to represent high tide. And they tell us to label all of our high tide and low tide points, so I'm going to label that 0, 36. All right, it tells us that every 12 hours it's going to hit high tide again, so if we were to go all the way over here 12 hours later, it would be up at high tide again, so we could put a point at 12:36. Now we know that low tide was going to occur halfway between that, so halfway between 0 and 12 would be 6. So at 6, I could put a point at 22 because that's the height of the water at low tide. All right, so then we have to label that too, so that'll be 6, 22. All right, and then we could just keep going with this. So, basically every 6 hours it's hitting high tide, low tide, high tide, low tide. So 6 hours after this, so 12 plus 6 is 18. So at 18, it's going to be back down at low tide, and then 6 hours later at 24, it's going to be back up at high tide. So if we label those 2 points, that'll be at 18:22 and at 24:36. Now you don't have to label the points halfway between high tide and low tide, but I just like to, just to have a more accurate graph. So if I wanted to find my midline, halfway between 36 and 22, you could do one of two things. You can just kind of count your way in if you want, or if you prefer, you can just kind of off to the side here do 36 plus 22 and divide them by 2. We could find the average of those two numbers. So if you want to find the average of those two numbers, 36 plus 22 is 58, and 58 divided by 2 is 29. Okay, I was finding the average of those two numbers, so my midline would be right here at y equals 29. So halfway between 0 and 6 is 3. So actually I chose to, a nice way to label this. It made it easier for me. So at 3, we're going to be up at a height of 29. And again, you don't have to put these points, but it just makes your graph a little bit more accurate. All right, so halfway between 6 and 12 would be 9. So at 9, I'm going to put a point, again, at a depth of 29 feet. All right, our next one would be at 15:9, halfway between 12 and 18. And then halfway between 18 and 24 would be at 21:29. I think I said 9 before for this, but that was 29. And you could just go ahead and connect those to make a cosine curve. Well, 2 periods of a cosine curve, which is what they wanted. In part B, they want us to determine the values of A, B, and C in the model of the equation. So, we know A right here is the amplitude, B is our frequency, and C is the vertical shift. All right, so let's find A. Let's find the amplitude. We'll do that over here. So we know the formula to find the amplitude is just max minus min divided by 2. All right, well, the maximum point on this graph is 36, and the minimum is 22. So we'll do 36 minus 22 and divide that by 2. So 36 minus 22 is 14, and 14 divided by 2 is 7. So if we go back to our equation over here, we'll have D equals, we can replace that A with a 7. So far we have 7 cosine All right, now next thing we have to do is we have to find the frequency. So to find the frequency, we're going to have to use our formula. Let me just kind of section this off. Period equals 2 pi over frequency. All right, well, the period is the horizontal length of one complete cycle. So we could see that it takes us horizontally 12 hours to complete the cycle. So I'm going to plug in a 12 for period. And I'm going to bring down the 2 pi over, and I'm going to call frequency B, because that's what it is in our formula. So just put a 12 over 1 and cross multiply. So 12 times B is 12B. 2 pi times 1 is just 2 pi. And to get the B by itself, which is our frequency, we're just going to divide both sides by 12. And since 2 divided by 12 simplifies to 1/6, we're left with 1 pi over 6, which is just pi over 6. So that is our frequency, so we can now go back and replace that for the B in our formula. All right, we can bring down our T, and the only thing we have to find at this point is the vertical shift. And I'm just going to do that using our formula. Let's see, I'll kind of section this off again. For the vertical shift, the formula is just max, the max value, minus the amp. So since our maximum value is 36, and we found the amplitude right here to be 7, 36 minus 7 is 29. So I can replace that for the C in my equation. And keep in mind, we actually found before that the midline here was at y equals 29, so that's always going to match up with your vertical shift. All right, so the never-ending problem, we're finally on part C. It says, tanker boats cannot be in the bay when the depth of the water is less than or equal to 25 feet. So they want us to determine all points in time t on the interval between 0 and 24 when tankers cannot be in the bay, and we're going to round all of our answers to the nearest tenth of an hour. All right, well, first thing, keep in mind, I would just, if we want to figure out when they're going to be less than or equal to 25 feet, I would just, in my calculator, I would graph this function under y1, and since we want to figure out when they need to be less than or equal to 25 feet, under y2, I would just graph y equals 25. Now, when you go to graph, so in your calculator, these are the two functions we're going to graph. Now, keep in mind, in your calculator is set up in degree mode. So when you go to plug in this equation, instead of using a pi, we're going to write it as 180. So under y1, this is the equation you will type. Under y2, this is the equation you're going to type. Now, your window is probably set at a standard window, which goes from -10 to +10 on the x and y axis. So what we want to do is we want to set our window to match the window from above in part A. So in order to do that, I would just, let's see. Okay, the minimum x value that we're going to need is 0. And the maximum x value that we're going to need is 24. And then the minimum y value we're going to need is 22. And the maximum y value that we're going to need is 36. So if you go to window, just change your window to match up with this. And keep in mind, when you finish the problem, it's a good idea once you clear out your equations to hit zoom 6 again, so it brings your calculator back to a standard window. Okay, so once you hit graph, you should see a graph that looks like this. So this right here would be the 2 periods of our cosine curve, and this right here would be the line y equals 25. So we know that the tanker boats cannot be in the water when the depth of the water is less than or equal to this line. So it can't be in the water from here to here, and it also cannot be in the water from here to here. So we want to figure out what times this occurs. So what we're looking for is the x values of these 4 points of intersection. Okay, we're looking for the time, which is the t values or the x values. All right, so in your calculator, you can go to find the points of intersection. You can go to second trace, go down to option 5, which says intersect, and then move your cursor near the point of intersection that you want to look at. So I'm going to first look at this one. Okay, so in my calculator, I guess I'm going to do a little bit of rounding here, but in my calculator, it tells me the x value at this point is, well, I know they say they want it to the nearest tenth, but let's just for right now look at it to the nearest hundredth, and then we'll decide how to round this. So it gives us 4.16, and then I'm just going to put 25. So this is the time. This is really what we're looking at. Now, I mean, usually if you were going to round to the nearest tenth, you would round to 4.2. But what happens is, if this point is at 4.16, if you wait until 4.2 seconds, the tanker boat is already going to have gone to a depth that's less than 25 feet, so that's not going to be allowed. So when they say to round to the nearest tenth, even though this is a 6, you're going to have to round down because you want to stop that tanker boat before the water gets to be a depth of 25 feet. So I'm going to round this down to 4.1 seconds. All right, now that's going to basically happen. You're going to have to, round for each of these points. So if you go back to intersection in your calculator, and this time you move the cursor on this point of intersection, I found the coordinates to be approximately 7.8425. Now, with this right here, if this point is at 7.84, if we decided to round this down to 7.8, well, 7.8 is over here. This is going to be too low for the tanker boat to be in the water. So, in this case, we're again going to have to round, this time we're going to have to round up. That way, it's not underneath the line y equals 25. The tanker boat cannot be in the water, under 25 feet. So, or less than or equal to 25 feet. So what we're going to do here is we're going to round up to the next tenth. That way, the water is high enough so the tanker boat can go in the water. So this time, we're going to round this number up to 7.9 seconds. You can do the same thing with the other 2 points of intersection, but you'll find that this one, you're going to have to round down to 16.1 seconds. And this last point right here, you're going to, again, have to round up, and you'll get 19.9 seconds. So when it says to determine all points, well, we know that the tanker cannot be in the water from 4.1 seconds after high tide until 7.9 seconds after high tide. So what we can say is that tankers cannot be in the bay between 4.1 and 7.9 hours after high tide, right, from here to here, or from 16.1 to 19.9 hours after high tide, from here to here.